Yep, we've got your screen.
Perfect. Okay. Well, welcome to this month's CFCA Nose session about Stir Shaken. Quick kind of history where what we've done so far and where we're going with these nose sessions. So last month we did a deep dive into Shaken authentication. Previous month was public key infrastructure. This month's going to be a deep dive into Shaken verification, and then out-of-band Shaken will be the next one, and then we have some future topics to go in as well. Before I get into the deep dives every month, Donald is going to talk about recent regulatory industry news that's happened since our last meeting, and we'll end with some time for discussion to answer any questions. Some quick background about TransNexus. TransNexus is a software company. We've been doing Stir Shaken for years now, and before that we've done a lot of toll fraud. That's kind of how our involvement with CFCA prevention, toll fraud prevention, and least cost routing, and a number of other functionality that we provide to our service provider clients. The presenters today are going to be Donald, who is our marketing manager. He's going to go into some of the recent news about Stir Shaken, robocall prevention, things of that nature. And then myself, I'm a software engineer, and I'm going to talk about Shaken verification. And with that, I'm going to hand it over to Donald to go into the recent news.
Well, thank you, Alec. Good morning again to everyone. Recent happenings and also some future happenings. You may recall from our last get-together that we talked about the FCC issued their report and further notice of proposed rulemaking for the implementation of the TRACE Act. And they've gone through 2 rounds of reply comments, and there are a lot of comments. Many people have filed comments and ex partes with the FCC on the order and the questions about future topics for discussion. We went over those a little bit last time. It's going to catch up with what the latest round of reply comments were on the next slide. Also, just in general robocall news, the whole purpose is to another tool in the toolkit to prevent unwanted and illegal robocalls. The FCC is really clamping down, and they issued a notice of apparent liability. That's the first step in going after somebody for breaking the law and robocall spoofing, with the biggest fine ever, $225 billion. They did that June 9th, and that same day, 7 state attorneys general filed lawsuits against the same telemarketers. So this is a big deal. There's a lot of determination to tackle this problem. And you may have heard us talk before about out-of-band Shaken, and we're going to go over that in next month's deep dive topic. And really looking forward to that. That's an interesting complement to Shaken. It's Stir Shaken, but with another way to get the identity token there, in case there are practical reasons why it's difficult to do that. So it solves some practical problems. And the standard continues to be developed in the ATIS IPNNI task force, and the latest version was just posted last Friday. And that's available for public viewing. It describes the problem and what the standard looks like, how that would be implemented in software to get the token from the originating service provider to the terminating service provider. It's also going to be covered in a virtual summit. Alec is going to present a session on how to build a CPS. And you'll learn more about the CPS. That's basically the place where you send the token. And he'll show how to do that and also talk about it on our call next month. So with the next slide, we have just a few points or highlights from the latest round of comments, the FCC order, and further questions that they want for discussion. Again, as in the previous round of comments, there are many who expressed a concern over the lack of the IP interconnection. So a typical example might be a NTCA member, and they have IP-enabled equipment, so they ought to be able to do Stir Shaken, right? Well, no, because even though they could install the software on their network and use their IP-enabled network to do authentication and send it out, it just won't get there because their very first connection to the wide world is on a TDM switch. So they a TDM interconnect, and so that's their problem. So there's a lot of a problem that they described and a number of others described, and there's a lot of conversation about that. That's one example of a situation that out-of-band is helps with. It helps get around that problem. And our next No Shaken session, which will be on July 21st in the afternoon this time. Usually they're at 11, but this one will be in the afternoon at 2. But Alec will go through a deep dive on out-of-band shaken to show you how that works. And again, it's also a topic on this summit that's coming up. There were many comments on whether intermediate carriers should sign calls. So of course, the call leaves the originating service provider, it can make several hops. And there's universal agreement in the comments that yes, intermediate carriers should be required to pass on band band attestation and identity token in the SIP header. Everybody's on board with that, but the question is, well, what if they get a call that's not signed? Should they sign it with a C attestation? And so that's provoking a lot of discussion. And some of the very largest carriers, for example, Verizon is one, and some others have questioned, is there even a benefit to signing gateway attestation? It says, I don't know anything about the customer. I don't know if the customer should be able to use that number and caller ID. I'm just telling you where I am, and you can trace it back to me because I'm going to sign the call, stir shake, and using a C attestation. And some of the larger carriers are saying that's going to flood the network with all these tokens, and they've done the math, and they said they would need a lot of resources to process all those, to handle all those C attestation headers. So they're saying, we've got the traceback group anyway. They're doing pretty good tracing back things. The whole purpose of having a gateway attestation was to help with traceback. Do we really need it? So that's the type of debate that's going on. A lot of interesting things going on in this world. With that, that's our catch up on the news, and I'll turn it over to Alec for a deep dive into verification.
Yes, thank you, Donald. So to talk about verification, I want to quickly remind everybody what the PKI model and the call flows look like for stir shaken, just as a quick refresher, so it's a little easier to talk about the verification process. So the verification process really hinges on this trust model that Shaken is built on. And so the policy administrator issues a list of certificate authorities. These are approved certificate authorities to all telephone service providers. So they know which certificate authorities are part of this trusted ecosystem, and then they maintain the list of telephone service providers that just is what allows certificate authorities to know who to issue certificates to. But so the key thing here is that the policy administrator provides the list of trusted certificate authorities. And in the US, there are currently 2 commercial certificate authorities, TransNexus being one of those 2 certificate authorities. But in some countries, it looks like in Canada, for example, it looks like there are not going to be any commercial certificate authorities, at least not initially, and the policy administrator will itself actually be the certificate authority. There will only be one, although there could potentially be more in the future in Canada. So even in other countries where things are going to be a little bit different, it all still hinges on the policy administrator is the central root of trust. And if they say you trust these certificate authorities, then you trust them because they said you should. Or if they say, you just trust our certificate, then it's effectively the same thing. And when a call is made, that call goes from the originating service provider, it's signed. So a passport is created and sent through the network that's cryptographically signed, and then it gets to the terminating service provider where it's verified. And as Donald kind of alluded to, all those intermediate providers, they don't do anything. They're just passing it through. They're not modifying the passport. They're not even looking at the passport. All they have to do is not remove that header, the identity header, which contains the passport. Now, when a call comes in to a service provider's network that's been signed, it's going to have an identity header that's going to look like this. It's a big blob of base64 encoded. It's a JSON web token, really, so it's base64 encoded, and it's kind of looks like a bunch of nonsense. But you can base64 decode that. Now it's not decrypting, it's just decoding. It's not encrypted. Anybody can decode it. It doesn't require any special permissions or anything like that. If you have it, you can decode it. And you're gonna get something that looks like this. And these fields are kind of in two categories. There's a header, there's a payload, and then there's a signature. And the signature is not shown here. That's just the kind of the signing of those two previous fields. It doesn't actually contain any usable data. So the header just contains some background information that you need to be able to verify this token, the algorithm that was used to sign it. And this is done so that as cryptography advances, computers get faster. You need new algorithms because computers are better at breaking those algorithms. These can be updated. This is kind of why you embed those algorithms in there so that you can change over time. And then some passport shaken information. There's some extensions that can change those types and PPT values. And then the X5U is really the kind of most important of the header. This is a pointer that points to the certificate. So when the service provider signs that call, and we talked about this last month, but just as a quick refresher, they're going to sign that call and they're going to sign it with a certificate that is publicly accessible. And this certificate URL here is the link to that publicly accessible certificate so that anybody can then verify that. And then the payload. This is really the core information here. So just to kind of skip around in order a little bit, we've got a destination and an orig value. And these are the called number and calling number respectively. And these are used to prevent that token from being taken out of a call and associated with a different call. You wouldn't want someone to sign a phone call and someone in the middle that's untrustworthy takes that token out and puts it with a different call, and then it looks like it's signed. So that token is only valid for that number calling that number, a pair of numbers. And this issued at, this is a Unix timestamp. So this is the number of seconds since the Unix epoch, which is 1970, January 1st, 1970. So it's the number of seconds since there. So it's a timestamp. And so what this is used is when you're verifying a token, you can make sure that that token was recently issued, because the token should be created right when a phone call leaves the originating service provider's network. So as a terminating service provider, you should receive that token and that phone call within seconds of that token being created. So again, this is to prevent replay attacks where someone calls someone else, a token is created, and then a bad guy were to somehow get that token, they could fake a call hours, days later if you didn't have some timestamp. So that's what that's for. And then you've got the attestation and the origination ID. The attestation and the origination ID are actually what's specific to Shaken. So this is a stir token with kind of the Shaken things built on top of it, which is attestation and origination ID. But under the core technology here is stir. So the attestation value is something that we talked a little bit about last month, and I'm going to go quick brief discussion about that as well. And then the origination ID is that opaque value that identifies the calling party so that you can use it for analytics or for traceback purposes. Now we've kind of talked about this all these different fields, and I just want to quickly overview the verification steps. Not in too much detail, but a little bit so that you can kind of understand when you verify a call, what it's truly telling you. I think there can sometimes be some misconceptions about Shaken and robocall prevention with analytics and the differences in what they provide. So when you receive that call, the first thing that you do is you dereference that X5U to get the Shaken certificate. So going back here, that's this URL right here. You just dereference that. You go get it from the publicly accessible web server that's hosting that, and now you have the certificate. And then you can verify that certificate chains up to a root certificate that's in your trust store. So again, the policy administrator as a carrier supplied you with the list of all the certificates to trust. That's your root trust store. And then when you get this random certificate that you've never seen before, you can cryptographically verify that it was issued by that certificate authority or one of the certificate authorities in your trust store. And there may be an intermediate certificate, or there may even be multiple intermediate certificates where the root certificate is used to issue another certificate, which is then used to issue the Shaken certificate. And this is done from a CA security perspective, where you don't want to use that root certificate just issue every certificate, because then if it's more likely to get stolen, is really what it is. From a cryptography standpoint, it's better to have that offline, inaccessible to anybody, and have issuing certificates because it's easier to revoke. So that's why there's almost always going to be an intermediate certificate, but it doesn't really matter how many certificates are in that chain. Once you've verified that that certificate was issued by the or one of the root certificate authorities, then you know that this person who has this certificate has been approved by the policy administrator, because the policy administrator would only give SPC tokens to approved people, and certificate authorities would only issue certificates to carriers with SPC tokens. So that's kind of how that triangle of trust plays in. Now you need to actually verify that the shaken certificate that you just verified was actually used to sign the passport. So that's where you verify that passport and that signature, that third section in the passport here. This is the signature in this one from here to here. This is verified to make sure that this content right here wasn't changed. The header and payload weren't changed by anybody, and it was signed by the person who controls the private key in that certificate. And then you also need to verify that that passport was recently issued by looking at that issued at timestamp. We already talked about it a little bit. And then of course you need to make sure that the contents in the identity header, the destination and origination ID, match what's in the SIP invite. And this is really important, again, to prevent replay attacks where you reuse a token. Now, once you've done all of that, what you now have is confirmation that the attestation level and origination ID that are in this passport were issued by someone in the Shaken ecosystem and are intended to be associated with the call that you received. That's what you now know. It doesn't mean that it's not a robocall. It doesn't mean that it's not someone trying to commit fraud. It doesn't mean anything about the intent of the call or anything like that. It just means that you can trust that the attestation level and origination ID were provided by somebody that has some level of accountability. So as a carrier, if you were to put an attestation level of A and it was not somebody that you could trust, and someone received a call and complained, you could get in trouble. If you continued to do that over and over again, you would likely get removed from the Shaken ecosystem. So it's a method of saying we can guarantee that we can go back to the person who did this and punish them if they shouldn't have done this, and that's why you should trust the information here. But it doesn't actually guarantee that it is trustworthy information in and of itself. And it definitely does not provide any information about the purpose of the call. A robocall will have A-level attestation if it meets the requirements for an A-level attestation. And using call analytics, you can determine that that's a robocall, and it vastly improves your ability to determine that that is a robocall, because robocallers will have a much harder time spoofing calls, which is how they get around the analytics. Now, I want to just quickly highlight these attestation levels, just because I know we talked about them last month, but it's going to come up here in a moment when we talk about what you do once you've verified this call. So just as a quick reminder, the A attestation, that's the highest level of attestation. This means that as a service provider, you know that the person who made the call has authority to use the number, and you know who they are. B, you know who they are, and C, you don't know anything. So we talked about that last month, so I don't want to touch too much on that, and then feel free to look at the YouTube video of this after and read this information to get a little more detail if you need that. But why this is so important is, what do you do with that call once you've verified that call and you say, okay, this is a attestation A or C or a B level call, now what? The goal here is to prevent robocalls, right? So maybe you want to display something to your customer. Maybe you want to just use this as part of your analytics engine. So when you're verifying calls, it can be an input into that analytic function that decides, based on machine learning or many other options, if this is a robocall. But one of the things that a lot of people are talking about is presenting at least some level of information to the subscriber who's receiving this call, to tell them that this has been verified. And Comcast actually is the one who proposed this structure here. So here, we've kind of got a table of different scenarios So we've got the shaken outcome, whether the call was verified or not. And I'll talk a little bit more about what I mean by that. Right now, I'm kind of really just saying that this call was verified, not a specific level of attestation. The reputation. So a big part of shaken is that this plays well into CVT or call analytics, where you're doing a reputation lookup. So you have some reputation, some historical data that tells you, oh, this calling number has been used a lot for fraud, or has been used a lot to commit illegal robocalls, or is an AT&T mobile subscriber's number who's just calling their family members all the time. It's a low risk. That input, combined with, of course, the privacy header, because you don't want to present caller display name information if that privacy header is set. And when you take these three inputs, this can kind of show you what the output could be, what the subscriber might see. And we've broken it down into two categories, this digital display and a character display. And what we mean by that is really a smartphone and a dumb phone. So if you have a phone that maybe it's an iPhone or an Android phone, or maybe it's the latest and greatest Polycom phone with an LCD display that can be modified to have green checks and things like that. This is where you can display a logo or just a check mark, something a little bit more advanced, versus the character display is something with just that 15-character display, your old POTS landlines, things like that. So what the proposal that Comcast has made is, and this is something that TransNexus implements in our software because we agree with this proposal, is that the caller ID is displayed for a good call. And you can put a green check for those smartphones or a V in square brackets at the beginning to indicate that this call was verified, if it's not a private call. If it's a private call, then you put the word anonymous, or some people say something slightly different, restricted, but something along those lines. And again, a V in square brackets in front of an anonymous call. And this is what this is telling the subscriber, is that we verified that this isn't a spoofed number. We can't tell you who it is, but it's not spoofed. And then if it's verified and it's a robocall, or a call that has a bad reputation, that's known to commit fraud, that's known to do bad things, maybe you block those calls, or maybe you don't block those calls and you display spam to the subscriber. And you can actually this is where people get confused, or maybe don't realize kind of the intention of call analytics and shaken. You can say verified spam. I know that this is a number that has been used to commit spam, and this is the person who controls that number making that phone call. And then if that call has not been verified, or if the verification failed, generally it's agreed upon that the most likely reason verification is going to fail is because of a network issue, not because of attack or because of malicious intent, but just the network issues, things like that. So most people agree to treat those the same. The general consensus is to do nothing, not to put an X or a red X or anything to indicate that this is a bad call, but to just do nothing and have a positive indicator. Obviously, a big part of the reason for this is because right now, virtually no calls are verified. And so, having calls that all the calls today suddenly just say X because they're not verified would not be a very well-liked change. So most people agree, okay, if we put a positive indicator on the good calls and treat everything that's the way it is now, just as the way it is now, don't do anything special with caller display name. Now, what actually powers all this to happen under the hood? The character display is pretty simple. You're just modifying the caller display name before you send it to the subscriber and stuffing a V in the square brackets in front of it. Nothing particularly special there. But the digital display, that green check, the way that that's generally done is a parameter called verstat. And what that verstat looks like is this. So in that P asserted identity that's going to the enterprise or the class 5 subscriber that's receiving the call, you can do these two things here. You can modify the caller display name to put that V, and then add this verstat parameter, which is a user parameter in the SIP URI. And the verstat has 3 values: TN validation passed, TN validation failed, and no TN validation. Now, there's been a lot of recent discussion about this verstat parameter because there's a bit of a disconnect in kind of what people want to use it for and what it can actually provide. So if the call is attestation level A, there's no doubt in anybody's mind, verstat, TN validation passed, you can put a green check because that attestation A has indicated that the originating provider knows the customer who made the call and knows they have the right to use the number. But what about attestation B? What about attestation C? I mean, attestation C is really not providing anything about, this is a customer that you can trust, or at least say customer you can trust, a customer we can go stop and shut down if they're misbehaving, and definitely not saying anything about the use of the calling number. So putting a green check on the display of the subscriber probably doesn't make sense for a call that was signed with attestation level C. So the general idea, and something that TransNexus does as well, has been to only put verstat TN validation passed if the attestation level is attest A. Now this works great for your class 5 subscribers, but what about enterprises? A lot of discussion has come up with enterprises and what do they want? And most enterprises are saying that they actually want the identity header. They want to do the verification themselves. Doing a verification, we just kind of walked through the steps. So it's obviously a little bit more complicated than what I listed, but it's not that difficult. And most enterprises want to be able to verify the call and look at that passport as it was originally issued so that they can make their own decisions. The problem is right now, the list of trusted certificate authorities is only accessible to service providers. It's not currently accessible to enterprises. And because of that, enterprises can receive a passport, but they can't actually verify that it was signed by someone in the Shaken ecosystem. And for this reason, the verstat parameter is being used a little bit differently in those situations. The TN validation passed is used if the certificate verification or the passport verification is successful, regardless of the attestation level. And then the attestation level is something that the enterprise is going to look at. So obviously, verstat being used differently if it's an enterprise or a class 5 subscriber, it makes it a little bit complicated to implement it. So there's been a lot of discussion about maybe we need more complex verstat options instead of just TN validation passed. Maybe it should be TN validation passed A, B, C, all sorts of different information. But that's not something that a final decision has been made yet. Again, I'm sorry to kind of just talk about the issue, and not provide a solution, but that is something that is definitely being worked on and discussed within the standards. And I will mention another thing. There was a proposal to update some of the standards documents to say that only service providers can access the CA list. And that proposal was rejected. And that proposal was made to make it in line, the standards documents in line with what was actually happening. And that proposal was rejected, and the agreement in the working group was that the STIPA needs to change to enable that CA list to be accessible by anybody. So anybody can verify a passport instead of just service providers, which will potentially allow verstat to be used really only for class 5 situations, and enterprise can do the full verification themselves and they don't need to rely on the service provider doing anything. So I don't know what the timing on is going to be for that to happen, or if it's going to happen. That kind of change to the document was just rejected, I think on the 12th or so of last week. So it's a recent event. But that's a little bit of kind of what this verstat looks like. Now we have a future deep dive that's going to go into a little bit more detail about rich call data, but I want to quickly touch on it because I think it's really the most interesting part of the Shaken, especially from a verification side. So, today, in the way most things works is you have the CNAM lookup where you receive an inbound call, you do a caller display name lookup, you can get like 15 characters and put that in the caller display name field. Here in asserted identity is the display name, and then send that to the enterprise or class 5 subscriber, and that's what shows up on the handset. 15 characters, enhanced CNAM allows a little bit more information, but nothing great. And with all this rich call data, and with all the Shaken cryptography, there's been a proposal for something called rich call data. And this is where you're adding a lot more information into that passport. So previously, you know, we said the passport has the calling number, called number, attestation level, a reg ID, and issued at timestamp. Well, now we're adding this object called RCD, rich call data, into it, which can contain a whole bunch of stuff like a display name, a call reason that was actually just recently added and hasn't even been put in the final accepted version, but that's in the latest draft. URL that references a logo, a URL referencing a website, a JSON contact card, or a URL referencing a JSON contact card. A lot of interesting stuff that can be put into that passport so that when the call is received by that enterprise or that class 5 subscriber, their handset could do something. So, you know, here's a kind of a mock-up of how some of those fields could be used. That caller display name that's sent in the invite could be used to kind of put that up here, and the call reason maybe could be put here, and the URL referencing a logo, you go get that logo and put that over here, and then of course you say that this call was verified, so this information is here. So instead of, you know, when you get a call from that Home Depot delivery driver, you don't know who it is and you don't answer it, now Home Depot can make sure that their logo shows up when you receive that call and the reason that they're calling you, and that's all cryptographically secure. It's not like caller display name where it's something that the terminating service provider is fetching from a database that who knows what it has, but it's something that's controlled by the originating party. And the originating service provider is kind of making sure that there's no bad actors in here. That is an important aspect of this that we'll talk more about in the rich call data deep dive, but it can be trusted, where if someone were to spoof this information, they could quickly be removed from the ecosystem. So this is going to open up the possibilities a lot in what we can do with Shaken and really make Shaken a lot more upfront and something that subscribers see and enterprises really start to benefit from to a much greater extent. So that's really all we had to talk about from a Shaken verification standpoint. As always, I do want to mention that we have a lot of white papers on our website that basically these deep dives are kind of following along with. So definitely go check out that Shaken verification white paper that we have that goes into a lot more detail about Shaken verification, as well as any of the other white papers that we have. And with that, I want to answer any questions that anybody has or